Hi, I'm Madhumita from first MSc Physics. I'm going to take a video teach on topic condensed matter physics, atomic scattering factor. Atomic scattering factor. The Borg equation gives the condition for diffraction from point scattering enters in which electrons have been associated with geometrical point of space lattice. Actually, a crystal or composed of atoms arranged on lattice point. Therefore, the focal condition is that scattering is done by cloud of electron which surrounds the nuclei and not by the point electrons. The introduction of X-ray with the nuclei is of course negligible. Since the size of the atom is of the order of X-ray wavelength transfer, therefore all the parts of the atom do not scatter in phase, and we will have to consider the interfluence of waves scattered from different parts of the electron diffraction. The radiation of the radiation amplitude scattered by the change distribution in an atom to the scattered by point electron is called the atomic scattering factor. The expression for the amplitude of the wave scattered through a given angle was first calculated by Born and subsequently in the same Watt simplified for by Mott. Considering the wave equation, del square psi plus 8 pi square m by h square e minus v psi is equal to 0. Equation 1. The solution of the equation which are looking for must represent a plane incident wave and scatter wave leaving the atom. Suppose we consider the incident wave to travel along the x-axis, then it will leave the form equation 2 pi I Vt minus x by lambda, and the scattering wave will have the form r inverse of theta equation r 2 pi I Vt minus r by lambda, where integral theta is the amplitude of the wave in the direction specified by the polar angle theta by psi. It can be shown quite general that it and be any function a solution of the equation. Del square psi plus k square psi is equal to x into xyz is second equation. Psi is equal to 1 by 4 pi in triple integration equation minus ik matrix r minus r dash by matrix r minus r dash and x dash y dash z dash dx dash dy dash dz dash is equation 3, where r is the vector xyz and r naught is the vector r dash y dash z dash. The function represent wavelength of the amplitude 1 by 4 pi and xyz dx dy dz by r. Fourth equation. Spreading from each element of volume, the equation may be written in the form del square plus k square psi is equal to 8 pi square m by h square v psi. Fifth equation. If follow therefore that psi minus psi naught plus triple integration 2 pi m by h square v x dash y dash z dash expression minus ikl k integration r minus r dash matrix by matrix r minus r dash del x dash y dash z dash dx dash dy dash dz dash is the equation. Is the equation most general solution of the equation, since the general solution is obtained obtained by adding to the potential solution of del square plus k square psi is equal to 0, which we have called psi naught. If we put psi naught equal to e power kx, the right hand side of expression represent the incident wave together with the scattered wave. The expression for the scattered wave is the same as that which would be obtained if we occurred each element of volume as scattered as wavelet of amplitude 2 pi m by h square v x y z psi del xy is the dx dy dz by r. all, all, all through it is theoretically possible to fix a solution to equation. It is found necessary in particle to assume that the wave is little absolute abstracted in the atom and all the scatter wavelets in particle to assume that the wave is little disturbed in the atom and all the scattered wavelets therefore starts in phase. This is equivalent to putting psi in equal to psi naught that u e dash k x. Suppose we call the amplitude of the wavelets scattered per unit volume when the amplitude of incident wave is unit per. Suppose 0 A to be the center of scattering medium and consider a phase OX such that incident and scattered ray makes equal range 0 with it. Consider a parallel plane distance x from it. Then the plane difference between wavelet scattered by the two plane will by mu. Psi where mu is equal to 4 pi sin by lambda. The resultant amplitude E naught by R of the scattered wavelet at the large distance R will therefore the E naught by R is equal to 1 by R triple integration E mu y p into x dx dy dz in polar coordinates becomes 1 by R integral 0 to infinity integral 0 to pi e power I m mu r cos theta r square dr sin theta d theta integral over theta we get 1 by r 4 pi integral 0 to infinity sin mu r by mu r p r square dr. Pr is 2 pi m by r square v rxy ryx, so that amplitude is 8 pi square m by rh square integral 0 to infinity sin mu r by mu r v r square dx. Since we have assumed as specially symmetric distribution, we know the Gaussian theorem. A square v is equal to 1 by r square del square r square dv by dr is equal to 4 pi p. E naught is equal to 8 pi square m by h naught integral 0 to infinity r cos mu r by mu square sin mu square by mu square r mu integral mu dr. E naught is equal to 8 pi square by h square r sin mu r by mu square dv by dr integral 0 to infinity sin mu r by mu cube r 4 pi p into r cube into dr. E naught is equal to 8 pi square me square by h square zf by mu square. Since we have assumed a symmetrical distribution we know from Gaussian's theorem, since v is equal to 2e square by r at origin. If is the atomic scattering factor, the atom moves expression may be written as E naught E theta is equal to m square by 2 r z my f lambda square by sin square theta. Reciprocal lattice to BCC lattice, A dash is equal to A by 2 A cap x cap plus y cap minus z cap. B dash is equal to A by 2 minus x cap plus y cap plus z cap. C dash is equal to A by 2 x cap minus y cap plus z cap. A is the side of the cube. B is equal to A dash B dash into x. C dash is equal to 1 by 2 A cube. But reciprocal lattice vector A star is equal to B vector into x C vector by A vector dot B vector into C vector. A star is equal to A by 2 minus x dash x vector plus y vector plus z vector by 1 by 2 A cube is equal to 1 by 2 2A x vector y vector minus x vector z vector plus y vector z vector plus z vector x vector minus z vector y vector. Crossing product of same vector is 3q theta 1 by 2a x vector y vector plus z vector x vector plus minus x vector y vector plus y vector z vector plus z vector x vector plus y vector z vector. Equation 1. From equation 1, A star is equal to 1 by A x vector plus y vector. B star is equal to 1 by A y vector plus z vector. C star is equal to 1 by A x vector plus z vector. Reciprocal lattice of FF lattice FCC lattice. From FCC lattice, A dash is equal to A by 2 x vector plus y vector. B dash is equal to A by 2 x vector plus z vector. C dash is equal to A by 2 z vector plus x vector. So the permittive transformation vector A star is equal to reciprocal lattice A star is equal to B vector into C vector by A vector B vectors into C vector. A power 2 by 4 y vector plus z vector plus x vector by A power 2 by 4 x vector plus y vector plus z vector plus x vector. Second equation from 2, A star is equal to 1 by A x vector plus y vector plus z vector. B star is equal to 1 by A x vector plus y vector plus z vector. C star is equal to 1 by A x vector minus y vector plus z vector. These are permittive transformation vector of BCC lattice such that BCC lattice is reciprocal to FCC lattice. Thank you.